Lesson 7.5, Application to Quadratics, and we're kind of continuing our discussion of what we did yesterday where we look at real-life situations and talk about how the quadratic formula and these different pieces and parts of it can kind of help us interpret what's really going on. So the first problem here, and really this is the only problem we're working with on the notes today, is talking about a rocket. A rocket is launched from the ground with an initial velocity of 224 feet per second. The height, h, in feet of the rocket at any given time, t, in seconds is, and then we get to the really important part of this, and that is, okay, they give us an equation. They give us an equation, and for all intents and purposes, this is the same as y equals 224x minus 16x squared. The reason I just wrote it like this was because if we're going to get any information out of this, if we're going to determine any of these questions, we could do the work by hand, but it's going to be just so much easier for you guys to use your calculator. So I'm going to go to my calculator and I'm going to go to y equals. And you'll notice that I already typed this in, right? I typed this in 224x minus 16x squared. The first thing that we're asked to do in part A is to fill in the following table. So I'm going to go to the table in my calculator, which means I'm going to second graph. And we can see that we've got all these different points in our table, and on our table we want to go all the way to 14. So you just be writing all these numbers down all the way to 14. All right? Now I already did this and I just kind of wanted to save some time, so here we go. Here are the numbers that I found. And you can pause the video if you'd like and copy these numbers down yourself from the video or just from my calculator screen, which you can still see most of. All right, so the next thing we're asked to do is to graph this situation. Now, I am not going to sit here and plot all of these points. I just really don't need to. I just kind of need a sketch. So I'm going to plot the end points, the roots, the solutions. I have 0, 0, and I had 14, 0, right? Those are just coming from my table, and 0, 0 was in my calculator. And then what do you think is the most important point to make sure I draw this parabola as close to being, good, perfect as possible? What do you think is the most important point? Okay, well, I hope you said the vertex. Well, where is the vertex? You know what? It might help to look at my graph. I'm going to look at my graph over here in my calculator, and I can't really see anything. Okay, the reason I can't really see anything is because I need to change my window. So let's go to my window, and this is a skill I have not done in a video yet, I don't think. In my video, I see that I can change my x minimum and my x maximum. Well, if I look over here, I'm going from 1 to 14 for my x's, so let's do the same thing over here. I'm actually going to do it from 0 to 14. All right, and then you don't need to mess with the next part. That's just telling us what to count by. So my y minimum, my lowest y value was over here at 0, so let's type in 0 for my y minimum, and my y maximum is, okay, right here, 784 is the highest y value. So we're going to type in 784. If you just change those four numbers, now when I graph it, I can actually see my perfect arc for this rocket. So when they ask me the question, when will the rocket reach a height of 528 feet, I've got a table to look at, but now I've also got a graph to look at. All right, so let's plot this thing. Let's plot the vertex. I think this is the most important point to really make sure I got the shape of this graph correct. So 7, and then 784. All right, so I'm going to say that's right about here. All right, so I'm just going to kind of easily sketch my graph. So now we have a really good idea of what's happening. All right, that's 784. All right, so when means we're going to answer with seconds. When will the rocket reach a height of 528 feet? Well, I've got a table. Let's just use that. I've got 3 seconds and 11 seconds. Right? If you look at the graph, 528 feet looks like maybe about here, right? We reach that height twice. When will the rocket reach the ground? Okay, well, I shoot it up. It's going. It hits here. So that right there is when I hit the ground, which was 14 seconds, right? When means seconds. The next question I'm asked is, when will the rocket reach its maximum height? Well, we really already talked about this being the vertex, right? This is the point that we're talking about, this vertex point. So when does it hit the maximum height? 7 seconds. What is that maximum height? 784 feet. I want you guys to associate this word maximum with the vertex, because the vertex is always your maximum or your minimum depending on what kind of graph you have. All right, finally, state the domain and the range of this situation. So my domain and my range. I want you guys for domain to put all real numbers, and then I want you to cross it out. Right? I talked a lot about how the domain for quadratics is all real numbers, which is true unless you have an actual situation with real data, in which case you have to just use the x values from your data. So, what is my domain? My x values go from least to greatest. The smallest x value in my graph is here at 0. The biggest x value is 14. So I guess my domain goes from 0 to 14. And don't forget your inequalities with x in the middle. My range looks like my highest point is way up here. My lowest point is way down here. So my y values are going from 0, right, from the ground, all the way up to 784 feet, right? That was the highest, 784. You could have also looked at the table and just looked for the smallest and the greatest values there. All right. Now, I do want to show you one more thing, and I don't usually do this, but go ahead and just kind of go with me on this next thing. Let's see here. We've got this problem, Joey jumping off a diving board. The equation of his pathway can be modeled by, so let's go ahead and let's put this equation in my calculator. And I've got negative 16 t squared, but I'm just using x, right, x squared, plus 96t, so I'm just using x, plus 112. All right, and I'm going to go ahead and change my window because I know what it is, so just don't freak out that you don't know how I'm getting this. All right, just kind of want to show y'all something. 256. All right, so take a look right here at my graph. We notice that it doesn't start at 0, it starts up here, and then it goes all the way down. So I guess Cameron's diving off a diving board, and this marks his progress, right? So this question right here, question D of this section here. How long does Joey stay above the diving board? Well, how high is the diving board? Because if we don't know that, we can't answer this question. How high is the diving board, guys? All right, you kind of got to look at the graph here. You need to have an understanding of what's happening. Look, I start here, and this is height. So either Joey can fly or levitate, or he's standing on something right here when we start, right? Look at your table. When x is 0, when the time starts, when x is 0, when the time starts, he's already 112 feet off the ground. So the height of the diving board must be 112, right? Because if he's starting 112 feet off the ground, he's standing on something, and that something is the diving board. So how long does he stay above the diving board? Okay, again, take a look at your graph, right? This, we're talking about how long is he going from here to about here, right? This is about 112. So how long is he above the diving board? Well, let's kind of count. Ready? 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds. So it looks like about 6 seconds. Now, I would be hesitant to answer that on a test because of how I figured that out. Just was kind of eyeballing it, right? You could also look at the table. So when I go to my table, notice that since I figured out the graph was the diving board was 112 feet off the ground, then it looks like I'm going from 0 seconds to, let's see here, to 6 seconds. Right, from 0 to 6 seconds. Well, how much time passes between 0 to 6 seconds? 6 seconds. All right, so that's just how I can double check that logic right there. And that's the only other question I wanted to show you guys today on the topic of applications. If I could sum up what I need you to learn from this lesson, it would be utilize your calculator for quadratics, mess with your window. Oh, you know what? Let me show you one more thing. If I want to get back to my normal window, because I know it kind of scares us, especially on a test, to mess with the window, if you want to get it back to normal, go to Zoom, And then you got this option 6, which just says standard. That's going to get you back to how your calculator normally looks and what you're comfortable with. So you can always get back here if you just go to zoom and then option 6, zoom 6. And then my graph is perfect like I love it. So, I mean, it's not helpful for this, but that's how I usually like it. So you guys utilize your calculator for quadratics. The table, the graph, the window, all those things are very, 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 very useful.